Hello, welcome to Topper Machine. I'm Josh Topper. So today's job is to actually get set up with a new cutter for the horizontal boring mill. So the Lucas boring mill, I've been running either a giant fly cutter that I built, or more recently I've been using these face mills. And this is the one I've been using. This is a 6-inch, but I have this bar here of 6-inch square to square up and make pretty, because we're actually making a new tool holder for the Mori vertical slaughter over in the corner over there. Now, I picked up this arbor. This is a 6 Morse taper for boring mill, and Kyle Vanover from Vanover Customs, he's got a YouTube channel, he brought this up to me. This is a 10-inch face mill, and so what we're going to do today is we're going to get this all set up for the boring mill. Make sure that it fits in my spindle, clean this all up, make sure the draw key that goes in here works, and then get it all mounted up on this face mill, get the inserts all changed out if we need to, and make sure it's ready to go. So let's get started. So the first thing I'm going to do here is pull this one out, and I've got the spindle locked just so that I could mill without worry of the spindle moving. We'll just run it out a little bit, actually a ways, to get it to where we can knock out the draw key and knock out the cutter. Now, this has been something that a lot of people have asked about, is this draw key, and I made this one quite a while ago, and I'm probably going to make another one or a couple styles, but all it is a wedge, and when you tighten this screw on the end here, so basically I'm simulating that, it pulls that wedge out and locks the tool into the spindle, so it's pushing here on the spindle and pushing back here on the tool holder itself. So very, very effective, works really well. A lot better than using the wedges that I've seen done in the past. This one's a little bit rusty. It's been sitting for quite some time. And so before I go and put it up in the machine and test fit it, I'm going to chuck it up in the lathe and polish the Morse taper surface lightly just to get the surface rust off, get it cleaned up a little. I feel little dings right on the tang there, so we'll get those knocked off as well. So I'm back from the lathe, and I realized that I could chuck up on the outer surface here, but I could also chuck up on this inner surface, and I can polish that as well. So that's what I'm going to do. Now, the nice thing about these Morse Taper 6 is they drop into the T-slot very nicely and gives you a surface to work on. Another thing we need to do is this bar will not fit in the groove of this cutter, so we're going to have to modify this bar as well. Well, I'm going to work on getting this out and see if I can get her to budge. It's moving good. And I do need to take this end off, so I'm not worried about using a real hammer. I just want to get it to move. That wasn't in there too bad. So now we can chuck up on this, hold it just by this little bit, and clean the whole thing up. Well, let's see what we got. Looks like she turns pretty good. So I'll grab some really fine emery cloth and we'll just polish this up. Well, that cleaned up real nice. Now, kind of an interesting one here. Somebody made this. That's weld. There's some weld spatter there. So somebody made this at one point, and they did a nice job. But we're going to find out once we throw it up in the mill if it really is good or not. Now, when I had it in the lathe, I couldn't do this surface. So I'm just going to quickly, just lightly hand polish that. Beautiful. Came out nice. Knocked off a few little high spots. There was some burrs here. Oh, it went in nice. Nice engagement. And if anybody's worried about me wrecking the taper, this is hardened. It is a hardened taper on there. So all I was doing was taking off the surface rust. Now we're going to make sure the draw key fits. And it looks like it's going to. Nope, the draw key will not fit. So we're going to have to go and modify that just a little bit. You know, every one of these is a little bit different. So we'll just make this one fit the Lucas and we'll go from there. So those of you who follow my Instagram and my Facebook have seen me modify one of these this way before, where I just clamp the tang and the vise, and then I'll go ahead and shim that up to the right height, which I'll figure out shortly here. Basically, I just put a square here, put a level on it, get it up, shim it, clamp it all down, clamp this down, and then we go in with an end mill and open that up. All right, so we're all clamped in. Got my shims down here, step blocks, clamped in the vise. The one I did a while back was the same setup and it didn't move. And this one looks like it's going to be the same thing. So now when I said we'll use a 5/8 solid carbide end mill, well, guess what? Whoever made this one didn't make the slot 5/8, which is standard. So I had to go digging through the collection. And here is one that is just undersized. We'll get this opened up and make sure it'll fit. That's a nice regrind. As you can see, there's this piece that's welded in here that they used for their draw key. And there our cutter fits in nicely. Doesn't hit either side, but this doesn't either. So we just need to take this down about 1/8 of an inch. Now you can see that cutter just barely extends out and just barely above, which is perfect. It's exactly what we needed. Okay, so that was a little harder than I thought it would be. So I went ahead, I slowed it down. We're in back gear on the Bridgeport, running 210 RPM right now. This will hopefully prolong the life of our end mill. Yeah, that sounds a lot better. Hopefully that isn't too hard. Well, that was just over 1/8 of an inch, so that should do it. So we'll go ahead and get this out of here and get it back over in the mill and try it again. That will fit. That'll work perfectly. Okay, so I got it up here on the face of the spindle. And yeah, it looks like maybe about 2/1000. 3. All in all, it's pretty close, and it'll be good enough for this. I mean, this cutter is really only for roughing. I probably won't use it for finishing on anything that is close tolerance. But overall, that's really nice. Center is a little off. We look like about 5/1000, but it looks like about 5/1000 consistently. 4 to 5, yeah. And the center being off isn't going to affect us too much. It's more having this flat to keep that cut consistent. That will affect a little bit, but not as bad as I would think. So we should be okay with this holder. You know, you always take a risk when you buy something used on eBay. So the next thing we got to do here is make this thing fit. And as you can see, it's too long. So this groove is 5 7/8 long by 1 inch wide. And the key is 1 inch. So everything should fit in there. It's 10 over 1 inch, so it fits nicely. And basically, so if we take 1 inch off of 5 7/8, we get 4 7/8. And that's getting into our keys, or our screws, cap screws there. So I'm gonna just mill it off just to the edge, leave a little bit, maybe 1/8 of an inch, and then I'll round that with the belt grinder. You know, this project is taking far too long, so instead I'm just gonna saw off the excess in the bandsaw, and then we'll clean up the rest with the belt grinder. Some things just don't require super precision, and it isn't worth wasting your time doing it. Oh, that should just drop right in there. Nice. A little bit of room to move around, but perfect. That'll work just fine. Let's see how the bolts fit. Oh, they don't. Well, next problem. So what we got here is, this is threaded 3/4 10. Not a big deal. I have 3/4 10 bolts. The face mill is built for 5/8 holes. So we're over here at the Bridgeport, and have you ever had one of those days where everything just goes to complete and utter shit? Yeah, that's today. This job that shouldn't have taken very long is going on about 4 hours because of little things here and there. The next one that I found was actually the bolt pattern is different in this cutter than it is in that arbor. Not a surprise, something I bought off eBay. You could tell it was homemade or shop made. Guessing the cutter they were using or whatever they were holding in there, driving with it, was probably homemade as well, because it's not a standard bolt pattern. So I've got it all measured out, figured out. We're going to go ahead and bore it. I've got a 800 thousandths end mill. It's a regrind that I had in the drawer, so it'll work out well, and we'll just go to it. It's a 6 flute, should work well. Now again, assuming this thing's hard, I'm running a little bit slower RPM. We'll put some oil on it, and we'll just make sure everything's locked and hope for the best. A little bit of a hard start there. All right, that is a hard tool, or the center cutting part of the end mill is bad. So we're going to switch to a smaller end mill, open those all up, and then go with the bigger one and open up to the size we need. All right, so this is a 5/8 solid carbide end mill. This is the one I was going to use originally to open up that slot for the keeper. This is working good, so I am going to go ahead and speed this one up. So I'm running about 600 RPM, and this is definitely a hard tool. Well, we made it through with that solid carbide, and it wasn't happy. That's the 5/8, so 625. We're going to open it up to 800 next using this 6-flute high-speed steel end mill. I'm going to run it super slow. You can get through hard stuff, you just got to run really slow and lots of oil. I'm probably going to actually set up the mist coolant for this just to stay safe, but I mean, we're not taking a whole lot out of there. That's the one I started on, and I mean, I waited a ways before we couldn't go further, so. Well, I'm making it through. I might be able to finish it with this end mill, but it's chewing it up pretty good. The big thing with this is it's lots of pressure, slow spindle speed, and the cool mist coolant seems to be the trick. That really does help. And it's helping to clear the chips because it's blowing them out of the way. But as you can see, it's a very hard start. Once you get started, then you really got to just stay on it. You can see it's just scratching, it's not cutting yet. And there it goes. Like I said, I hope I get through this entire part with this end mill because I don't have another one. Well, I made it through, just barely. They're opened up, that should work. I really hope it does anyway, because there's no turning back now. All right, let's see if this beast fits. And I decided against counter boring just because this was so hard, and there's still a lot of material there. The only thing I might do differently is get some SAE washers to put up under the heads, but I mean, for the most part, I got good engagement. And you know, all this is doing is holding it from falling off. The bar in there is the drive, so I think we're in pretty good shape. Wow, they all go in. Boy, that looks nice. It's quite the job to set up and do with them. Being that it's hardened, it didn't go well, but them heads are below the surface of the cutter, so I'm really not too concerned. Like I said, I might just do an SAE washer. We definitely need to change some inserts though. That one's bad. That one don't look too bad. That one's bad. That one's bad. That one's okay. Yeah, there's some pretty good sized chips in them. So we'll get the inserts changed out. Probably have to order some more, but I think this will work. So we'll have to give her a try. Well, I hope you enjoyed that. That was quite a job putting that all together. Actually, I'm going on 5 hours of working on this thing, trying to get it all together. This was quite a challenge, quite a tough job, but we should be in good shape for hopefully not next week, but the week after. I'm hoping we can get on this job and build that tool holder for the Maury vertical slaughter. So with that, until next time, get out in your shop and get it done right the first time. All right, now I gotta get this beast out of here without killing myself. Holy crap. Holy Jesus, this thing's heavy. Holy shit.